Yes, friends, as per the last lecture in which we have discussed the syllabus for our BSc first year second semester, and the paper was physics. Subject was the physics, and the name of the paper is Geometrical and Physical Optics, paper number 4th. Today we are going to start our actual syllabus. The name of the chapter is Geometrical Optics and Optical Instruments. In last lecture, we have seen that in geometrical optics and optical instruments, the article first, which here we are going to discuss, was cardinal points of an optical system. See friends, the name cardinal, the meaning of cardinal is nothing but important, means important points of an optical systems. In last lecture we have discussed that in all total there are 6 important points or cardinal points. But what was the necessity? Why there was a necessity to discuss or to give the cardinal points? See, in refraction phenomenon, what happens if we are using a thin lenses in which we can neglect the thickness for calculating the various formula. It is immaterial in that case from which point of the lens the distances are measured. But where this case we have to assume, if that case is a thin lenses, this approximation we cannot apply for an optical system which is consisting of a combination of lenses, means there are number of lenses, or the lenses which we are going to use, if they are thick, we can not neglect the thickness of that lenses. Therefore the scientist Gauss has been showed that if we are using any number of coaxial lenses, that lenses we can treat as a single unit without the necessity of treating the single surface of the lens separately. By the use of lens maker's formula, that formula we can apply the system provided the distances are measured from the hypothetical parallel planes fixed with a reference to the refracting system. See now, the points of intersection of their planes with the axis are called the principal points or Gauss points. And in fact, there are 6 points in all which characterize an optical system. See now, which are that points? That points are nothing but there are 2 focal points, 2 principal points, and 2 nodal points. See, in all total, there are 6 points, and the 6 points are known as cardinal points of an optical system. And the planes passing through their points and which are perpendicular to the principal axis are known as cardinal planes. Means that if we are here taking under consideration if the planes are passing through the focal point, they are that are the focal planes. If the planes passing through the principal points, that are principal planes, and the planes which are passing through the nodal points are nodal planes. See now, by the help of these things, we have to discuss what are actually principal points and principal planes. Now, again, see once again, which are principal points and principal planes. For better understanding, you have to learn this diagram or study the diagram very cautiously, carefully. In optics, there is a much more importance of a ray diagram. If we are not getting the idea of a ray diagram, then we are not able to understand the phenomenon which is occurring in optics. See now, this is a lens system, two lenses L1 and L2, and in this optical system which we are considering, which having principal focal points F1 and F2. See, this is F2, and in you can see the F1 in another diagram. When we are summarizing the both things, then you will get the idea where F1 occurs. Here, this is a OA, is a ray. This OA is nothing but incident ray. This is traveling parallel to the principal axis. This is nothing but the principal axis, traveling parallel to the principal axis, and it is incident at A. Here is a A, and is brought to focus at F2. See, when this is incident at this face of the lens, then it takes a path in this way and brought to focus at F2 in the image space. Say this is the image space, this is the object space, this is the image space, which is we are getting idea by this figure. The actual ray is then refracted at each surface. This is the refracted, actual ray is refracted at C, and this ray follows the path OA, C, OA, then B. This is the B, and F2 in this. If we extend here, see once again the geometry. If we are going to extending the OA array in forward direction, and the emergent ray BF2, this BF2, if we are going to extending it in a backward direction, and they intersects or they meets at this point of that optical system at H2, and when we are drawing a plane which is in this way, a plane we are going to draw to the point H2, and perpendicular to axis is called principal plane. See once again this plane. We are drawing this plane by the help of the point of intersection when we are extending in this OA ray in forward direction and this BF2 ray in backward direction, this point of intersection, and if we are drawing a plane through this point of intersection, then this is nothing but the principal plane of the optical system, and therefore the principal plane of the optical system is the nothing but the loci where we assume a refraction to occur without reference as to where the refraction actually occurs. See once again this H2P2 plane, and this H2P2 plane is nothing but the principal plane in the image space and is called the second principal plane. The point P2 at which the second principal plane intersects the axis is called as second principal point. See once again, P2 is the second principal point, and this is nothing but the second principal plane H2P2. This is nothing but the just I have been discussed with you that we have been considered an optical system having its principal focal points F1 and F2. At that time we have I discussed with you that later on we will see here is the point F1. See now, this is the F1. Then for this purpose we are going to adapt for the geometry of the diagram, that is these two lenses, and here again we are considering F1. Yes, this is nothing but a ray which is incident at this lens. By adopting the similar procedure, we can locate the principal plane H1P1. In last diagram, we have been located the second principal plane. Now we will locate the first principal plane. For that purpose, we are considering here the ray F1S, which is passing through the first principal focus. This is a first principal focus. See now in this diagram, the second principal focus here is it. Now here this is a first principal focus, and such that the refraction, when refraction phenomenon takes place, at that time it emerges out in this way at W, that is F1S QW. This is the path of this incident ray, and this QW is nothing but the parallel to the axis at the same height as that of the ray OA, means this is the height of this ray OA. This is the height from this axis. At the same height, this is emerging out to W. The rays F1S, see this F1S and QW, When we are producing that, that means F1, yes, we are producing in forward direction, and QW in backward direction, that intersects here, and through this point we are drawing a plane H1 P1, and this H1 through is called the first principal plane, and the point of intersection P1 of the first principal plane with the axis is called the principal point. See now, the both the arrays or both the planes, first principal plane and second principal plane, first principal point, second principal point, first focal point, second focal point, all these are summarized or drawn in this diagram. If you are uh, observing this carefully, you will get the idea about this diagram. See now, this is nothing but the optical system. In this optical system, we are taking two lenses, L1 and L2. This is the axis, and the OA as well as F1S. These are the two incident rays. When we are producing it, it intersects at H1 and P1, and same H2 and P2. Therefore, H2 is the image of H1. Thus, H1 and H2 are conjugate points. H1 and H2 are the conjugate points, and the planes H1 P1 and H2 P2. This H1 P1 and H2 P2. This height is H1 here, same height H1, and therefore we can say that H2 is the image of H1. Thus H1 and H2 are the conjugate points, and the planes H1 P1 and H2 P2 are pair of conjugate planes. It is also H2 P2 equal to H1 P1. See, because of at the same distance. The principal planes are conceptual planes and do not have the physical existence with the optical system. In this way, if you are able to keep in mind the geometry of this diagram, how these arrays are traveling, how it is incidentally, and how it is emerging, how we are extending at that point, and when the point of intersection takes place, through which we are drawing a plane, and by which we are getting principal planes as well as the principal point and focal points. In this way, very simply, we can see the cardinal points. In next lecture, we will see the next part of cardinal points, that is about the nodal points and all these things. Thank you very much.